In this video, I'm going to pose for you and then solve as an example a problem involving calculating the angular momentum of a point mass. So let's imagine that you have some mass. Let's say it's a small ball, really small. Let's say its mass is 15 grams. And it's moving downward at a speed, let's say it's 35 meters per second. And just for the sake of argument, let's make that angle 45 degrees. And ultimately, this mass is going to hit the end of a long stick. And the stick that it's going to hit is pivoted at the center. So we would like to calculate the angular momentum of that mass, m, about the origin, O, which is right here. You always calculate the angular momentum of a mass about a point. So you look in your book and you see the formula for angular momentum of a point mass is mvl. And the question is, what's L? We have the mass, 15 grams, although let's not make the rookie mistake, we're going to need it in kilograms. We have the speed, 35 meters per second. But what's the moment arm? It's exactly like we found for torques. The way you figure it out is to extend in all directions the velocity vector to find the line that the velocity vector lies on at that instant in time. It's a little bit like the line of action for torques. And this moment arm L is the closest distance that that line gets to the origin where you want to calculate the moment of inertia. So we need that thing for our lever arm or moment arm. And then what you end up having to do is solve a little triangle in here. We need this length, so half the length of the rod, and this angle here. Let's say that the rod has a length of, if we're just making stuff up, 3 meters. So this distance here is 1.5 meters. Could you figure out what this moment arm is? The imaginary distance that the mass would zoom by if the closest point it would get to the origin if it just kept on going in a straight line. So to me it looks like I got the hypotenuse here, and I got an angle, and this is the opposite side. So the opposite side is the sine side. So to me it looks like it would be 1.5 times the sine of 45 degrees. So you can evaluate that out to see what you get. But now we can get the moment of inertia. We need the mass, but in kilograms. We need the velocity, or the speed, 35. And we need that lever arm, which is 1.5 meters times the sine of 45 degrees. So you can bang that out on your calculator as well as I can. I get this, 0.056. But what are the units? We have kilograms, we have two factors of meters, and a seconds in the denominator. So kilogram meter squared per second, and that's the standard unit for angular momentum. But there's one last thing we want to think of. Is this a clockwise or a counterclockwise angular momentum? I think of it like this. This bullet or mass or ball, whatever it is going to shoot by the origin down this way, and if it were going in a circle, it would be spinning like this. So that's a clockwise angular momentum. That's a little bit awkward and takes some practice. So that's a clockwise angular momentum, and because of that, we'd be obligated to stab that with a minus sign. This will take a little bit of getting used to, but with some practice, it'll become easy.